All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue um, working on the content pipeline. I wasn't sure what to say. We are going to continue doing because, like, we are technically working on the content pipeline, but today we're going to be focusing more on um, various techniques to um, analyze transcripts because we have transcripts. So, like, part of the content pipeline is going to be generating transcripts out of the VOD audio. And that's the main thing, actually, that we're going to be analyzing in order to determine which sections of the VOD are clip worthy. At least for my specific type of stream where there's constantly, yapping going on in whatever regard it may be, whether I'm like ranting about something, or if I'm on a tangent about something, or if I just accidentally branched out into some other topic, or even if I'm talking about the current topic that we are, going to be that 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 the current that the present stream is going to be focused on. So regardless of what it is, the whole idea is my stream is a whole bunch of yapping. So the transcripts of these streams, they hold a lot of valuable information. Granted, the video of the stream would also hold valuable information to a certain extent, but a lot of my at least for my specific type of stream, give me a second. Yeah, at least for my specific type of stream, a lot of the let's say content, or a lot of the data that can be analyzed, you're going to get it from the audio, and therefore you're going to get it from the transcript. Okay, that being said, in the past, I did ask Gemini for some some ideas for how I could go about how I could approach this whole thing, and Gemini did give some ideas. Though what Gemini did is, at the time, I don't remember if. Oh, yeah. So, okay. At the time, I didn't really have only the transcripts in mind in terms of, analyzing the VOD. What I had in mind was that I wanted to analyze the VOD, just analyze the VOD. I wasn't sure exactly what I was going to be analyzing, and that's when Gemini kind of broke it down for me. Gemini gave me we started from the basics. Like, Gemini mentioned that, okay, first thing you need to do is break this down into different pieces of information that you can actually analyze, because the VOD by itself it's a video container, right? The video container contains video and audio. So these are two things that you can analyze. You have the video, in which the frames can be analyzed. You have the audio, in which the audio waveform can be analyzed. And additionally, you can run the audio through an automatic speech recognition model. And what was I, what was I, what was I saying? Hold on, wait. Zoned out for a bit there. Additionally, you can run the audio through an automatic speech recognition model and get a transcript for it. So at this point, you have data in, or you have the content of the stream in text form as well. So now you have video, audio, and text, and uh, that's what the rest of this document uh, explains. The rest of this document explains how I could analyze, like, the different bits of information, the different bits of data that I have. And then after doing the transcript thing, I realized that for my specific type of stream, I think I can get quite a bit from the transcripts. There's also the fact that if I try to um, do something with the video and the audio, I feel like that's going to really complicate things. So in my case, I'm sticking to just the transcripts because there's quite a bit of information that I can get from the transcript. Later on, I can probably add in some, I don't know, I don't even know how I'm going to approach analyzing the video and the audio. I haven't touched either of those yet. So far, I'm just doing stuff with the transcripts because, again, fortunately, in my case, because there's a lot of talking going on, there's a lot of information within the audio. So the transcripts they hold a fair bit of data, a fair bit of content, and so I can analyze the transcripts and do something with them. Now, what is that something? That's what I wanted Gemini to give me more ideas on. And so I asked Gemini the same question again, but this time I added in uh, some like a bit of extra thing there. I think in the previous prompt, which was this one, where was it? Yeah, which was this one. I stopped at what kinds of models should I be looking for? And that is here, right? And then I added this extra bit asking or saying, but even keeping models aside, I meant to say aside, but I wrote side. In terms of using NLP to analyze the transcript, extract useful information, and determine which sections would be considered clip-worthy, how do I even approach this? For now, I'm only analyzing the transcript, so it's all text along with the timestamps, of course. Guide me, give me ideas. I have no idea how to approach this. Give me a second. I need to open up my chat on my phone so that I can see the chat. Um. Okay. All right. So this was my prompt to Gemini, and this one, or the answer for this one, is more focused on analysis of transcripts using NLP. So that's what we're gonna look at here. So Gemini said this to identify clip-worthy. Oh, actually, there's another thing that I mentioned after Gemini gave this all of this information. I realized that I should have mentioned to Gemini that my streams fall more under informative or educational. They are not necessarily meant to be funny or entertaining in any other way. Usually, I'm either studying something or building something, be it software or hardware. I'm usually either studying something or building something on stream. So my streams are less entertaining and more on the informative side. So actually, I believe I got done reading this part already. So the reason why I felt the need to mention that was because I noticed that a lot of what Gemini was telling me here was like it was more to identify moments of excitement and funny moments and like moments with like a wow factor or moments that are like uh I don't know, entertaining in any whatever aspect, just wow factor in general, something that grabs the user's attention. And my streams are usually not like that. There isn't too much high energy stuff going on. There isn't a whole lot of like, screaming and laughing going on. It, that's not what I that's not the kind of stuff you're going to find in my streams. And so uh, running various types of analyses to find those types of things in the transcripts is not really going to yield anything useful. So then the next thing that Gemini suggested was this. Since your streams are informative, technical, and study oriented, hold on. Let me find a good place. Okay, right. Since your streams are informative, technical, and study oriented, the hype slash laughter detectors used for gaming won't be as effective. You need to look for pedagogical. I still don't know how to pronounce this, but or let's say pedagogical, uh, or whatever, pedagogical markers and epistemic shifts, which is changes in the state of knowledge. Here are 5 advanced techniques tailored specifically for technical slash educational content. Okay, so semantic drift. In a study stream, we often go from frustration slash confusion, which is debugging, to resolution, which is the fix. The technique, you use sentence BERT to track the semantic path of your speech. I actually didn't know about this. So this is interesting to learn. Semantic path. How it works. You calculate the cosine similarity between 30-second windows. When you're stuck on a bug, your semantic vector stays in a loop. A sudden leap in the vector space followed by a semantic shift using a model like sentiment shift followed by a sentiment shift usually indicates you've solved the problem or moved to a new concept. Clip value. This captures the solution, quote unquote, which is the most satisfying part of a technical VOD. Okay. Then we have discourse marker extraction. The teacher signal. Teachers and developers use specific meta talk when they are about to say something important. Technique: keyword slash phrase spotting combined with dependency parsing. Sorry, zoned out. Okay. Uh, keyword slash phrase spotting combined with dependency parsing. That's interesting. Dependency parsing. What is that? Let me look into this. Give me a second here. I'm new to NLP, and I'm performing analysis on the transcripts of a study slash building stream, or let's say on the transcript of a study slash building stream. Sorry, zoned out. Okay. Study slash building stream. I'm coming across a couple of different different, what do you call it, topics, topics slash terms that I don't know anything about. I'm gonna ask you about the various terms. Ready? Okay. Um, okay, so keyword slash phrase spotting and dependency dependency what? Parsing. Okay, great choices. These two concepts are often these two concepts are opposite ends. These two concepts are opposite ends of the complexity spectrum, are on opposite ends of the complexity spectrum, but they work together beautifully to help you understand what's actually happening in a transcript. Here's a breakdown of how they differ and how you'll likely use them. Keyword slash phrase spotting. Um, think of this as Control F on steroids. It's the simplest form of information extraction. You are essentially telling the computer, listen to these specific words and tell me when they happen. Okay. Oh, you know what? Okay. Okay. Hold on. Here's what. Okay, so um we're gonna need a list of keywords. Sorry, zoned out. So we're gonna need a list of keywords, and I feel like with the summary that we are going to be generating in the previous step, because we're going to be generating the metadata for the entire. Ooh, dude, not just the summary. Actually, we're going to be generating keywords as well, keywords and hashtags. Yeah, so I can add an extra step in there, and I can say, okay, I can tell the LLM that, okay, given what you are seeing here, give me a list of keywords. Yeah, yeah. Give me a list of keywords that you think belong to this uh, belong to this block of text, or give me a list of keywords that represent this block of text. I guess semantically, and then I can use that list of keywords in keyword slash phrase spotting, because I'm going to be doing the keyword generation based on the smaller summary of the VOD, but then I'm going to be using those keywords with KWS um, while doing the analysis on the bigger transcript, not on the smaller summary of the transcript. Okay, all right. Sorry, zoned out. Okay. In its simplest form, information, no, it's the simplest form of information extraction. You are essentially telling the computer, listen for these specific words and tell me when they happen. How it works, it looks for exact matches or variations like study, studying, studied, etc. within the text. In your stream transcript, you might use KWS to find every time the streamer mentions Pomodoro Python or deep work. Okay, deep work. That's new. Maybe that's like a deep study kind of thing because like we've done deep learning, but like deep work, that's interesting. Okay, anyways, the downside, it's dumb. If the streamer says I'm not using Python today, a keyword spotter just uses Python and and flags it as a match, even though the context is negative. Okay, I guess that's something to watch out for. Okay, we are dropping frames. So give me a second. I need to reduce the load on my connection. Okay, wait, are we getting like interference? Hold on, I need to. Okay, no, we're good. We're good. All right. Okay, then dependency parsing. This is where things get smart. Instead of just looking at words in isolation, dependency parsing looks at the structure of a sentence and sees how words relate to one another. It defines, no, it identifies the quote unquote head words and the words that modify them. How it works, it assigns a parent child relationship to words. It identifies the subject, the verb, and the object. In your stream transcript, the sentence, I'm building a custom mechanical keyboard, keyword spotting would just give you building and keyboard, but dependency parsing tells you I, the subject, is building, which is a root verb, a keyboard, which is the object. Why it's useful? It helps you understand intent. It can distinguish between I love this laptop and this laptop is driving me crazy by linking the sentiment directly to the subject. Okay, a pro tip for your analysis. Since you're analyzing a stream transcript, be prepared for disfluencies. Oh, ums, uhs, and restarted sentences. That is something that I do a lot. I kind of restart my sentences. I do a lot of all of that. I do that a lot. Give me a second. We are dropping frames again. Oh, there might be something that I could do here. Um, yeah, hopefully this might help. Okay, all right. Dependency parsers sometimes struggle with these because the grammar isn't perfect. You might need to clean the text, removing and like before running a parser to get clean results. That's interesting. Okay, and how do I clean up the text? Cleaning up stream transcripts is a unique challenge because people don't speak like they write. A raw transcript is usually a word salad of filler words, stutters, and run on sentences. To get a dependency parser to work correctly, you need to move from speech to text style to clean prose style. Here is a standard pipeline for scrubbing your data. Removing disfluencies. I didn't know that these are called disfluencies. I should remember that. In a way, I guess that makes sense, right? Disfluencies, probably because it prevents the sentence from remaining fluent because you kind of cut off the sentence. Okay, streamers use these to buy time while thinking or coding. If you if you leave them in, the dependency parser might try to link the word as the subject of your sentence, which breaks the logic. The target or the targets are like, actually, so yeah, you know, and so on. The method, simple string replacement, or God, you want me to do string replacement and regex here? Um, okay, let's try another technique, normalizing slanguage and abbreviations. NLP models are usually trained on Wikipedia or news articles. They might not know what GG means. They might not know that GG means good game or repo means repository. Okay. The strategy, use a dictionary to map these terms. No, hold on. Hold on. I have a question here. I have a question here. Um, would it help if I used a transformers based model? Like, would the transformers based models be a little more intelligent about this, a little more clever about this? Okay, let's see. Sentence segmentation, the run-on problem. Transcripts often lack periods. Um, a sentence might a streamer might talk for 3 minutes straight, resulting in one giant sentence. The solution: use an NLP sentence-sizer like the one in Spacey. It uses statistical cues to guess where a sentence should end based on pause or grammar rather than just looking for periods. Okay. Uh, Basic text normalization. This is a standard day one NLP cleaning. Lower casing, usually helpful. So Python and Python, which is Python with an uppercase and Python with lowercase, are treated the same. White space stripping, removing double spaces or random tabs. I don't think that should be an issue here because this is the result of an ASR model. I'm assuming the ASR model has done some amount of work here. Punctuation handling. Deciding if you want to keep hashtags or emojis. Okay, hold on. Okay, so I should mention I am using distill small en for ASR. Does that change things a little? Also, would I need to worry about this whole cleanup thing if I'm using a transformer based model, or even just directly using an LLM with outlines um, to get specific results? See, the reason I'm asking that is because LLMs are good at kind of just abstracting away all of this. Like, I could feed some text into the LLM and give it very specific instructions to do things, and it's going to do them. I don't need to worry about um, this kind of stuff, like, having to clean up the text, having to normalize the text, um, having to sentence-size the text, and all of these other like pre-processing tasks. I might not need to perform them. Let me see though. Okay, using distill small en is a smart choice for speed, but it definitely changes the cleanup game. Here's how your specific setup impacts the process. The distill small en factor. Unlike older ASR models that just output a words, lowercase stream of words. Fuck me, dude. Why was that so? Why did I get stuck on that? Whisper-based models are actually trained to predict punctuation and capitalization natively. The good news, you won't get a giant wall of lowercase text. It will try to place periods and commas for you, which makes dependency parsing much more accurate right out of the box. The small catch, because you are using the small version, it's more prone to hallucinations like repeating words or missing subtle punctuation or noisy audio compared to the large model. You know what? If that is the case, considering that I'm running the ASR in the cloud, why don't I just replace small with large? Or like I'll go to the distill small en checkpoint page and they've listed some of the other distill models that they have as well. Why don't I just use one of the larger ones if that's going to give me a better quality output? Because I'm anyways running this entire thing in the cloud. Well, the entire ASR thing, I'm running that in the cloud. Granted, it might take a little longer to get the output. However, we'll get good quality output. We'll get good quality transcripts. Okay. Um, you might still see things like I'm building a keyboard. Okay. All right. LLMs plus outlines versus traditional cleanup. If you shift from a traditional pipeline like Spacey to an LLM using a tool like Outlines to force structured JSON output, you need your need for manual cleanup drops significantly. Why LLMs change the rules? Contextual intelligence. An LLM understands that is a filter. If you ask an LLM to extract the main tech stack mentioned, it'll naturally ignore the ums and likes because it's looking for meaning, not just matching strings. Then robustness. Transformers are famously noise robust. They can usually see through a typo or a stuttered word to find the intended phrase. Then using outlines. Outlines is fantastic here. It allows you, okay, so what I'm getting here, wait, I'll continue reading that, but what I'm getting here is that I'm going to need a mix. Like, I'm going to need to use the NLP techniques that are being described here. I'm going to need to accomplish these tasks using an LLM, not using classic NLP techniques. That's what I'm getting from this. That I need to do these things that are being suggested here. I need to do these things. However, I need to use an LLM to do them. What I did. Oh, you know what I should do? I should open up the I should open up the conversation with Gemini that I had, and yeah, I should open up the conversation with Gemini that I had and continue this. And I should be like, okay, these are great. Do you have any more suggestions, like more techniques? Yeah, I think I'll get some. I think I'll be able to get more information or more ideas for stuff that I can do. Um, hold on. Okay, right. So, uh, What was mentioned here? Dependency phrasing. Okay, what to look for? Phrases like the key takeaway here is essentially what's happening is if you look at this part of the code, wait, I just realized these are actually things that I say, except for the key takeaway here is um, this other stuff. I usually say this kind of stuff. Essentially, what's happening is if you look at this part of the code, wait, I just realized, holy shit, dude. Okay, advanced twist. Use a NLI, natural language inference model. Give it a transcript segment and the hypothesis. The speaker is explaining a core concept. If the entailment score is high, mark that timestamp. That's interesting. Hold on. Give it a transcript segment and the hypothesis. The speaker is explaining a core concept. Okay, okay. If the entailment score is high, then mark that timestamp. Okay, question answer pairing, automatic FAQ. If you are answering chat questions, those are the most clip-worthy educational moments because they address specific pain points. Technique, oh, interrogative, interrogative. Let's say okay, interrogative sentence detection. How it works, you use a model like so and so question type to detect when you or the chat ask a how or why question. The logic, a question followed by 40 to 90 seconds of continuous speech from you is almost guaranteed to be a mini tutorial clip. Okay, 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 all right. Um, Information entropy, the deep dive metric. Information information clips usually have a higher density of technical entities. Technique named entity recognition plus TF-IDF over time. I forgot what TF-IDF was. I'd looked into it previously. I forgot what it stands for. But okay. Uh, okay. Informative clips. Yeah. How it works? You use a model like BERT base NER or a specialized technical NER like those trained on Stack Overflow data. Metric, you count the number of unique technical terms, example tensor, backpropagation, interface, asynchronous, in a 60-second window. A spike in technical density compared to your just chatting baseline identifies a deep dive. All right, okay. Content-based summarization. Dude, you know what? I should do something here. Let me close this and open up Gemini. Not here. Let's open up Gemini in the empty directory again so I can then access that conversation. However, yeah, we'll open this up and then I'll resume the conversation later on. I'm not sure what that's going to show once I open it up. And I also realized that I wasn't the only one that was running into these issues with Gemini CLI. Apparently, a lot of other people were running into these issues as well. And the issue wasn't even that I was clearing out the usage quota. The issue was with the client itself. The client itself was getting these bugs every now and then where it would report that I've used up my daily quota, even though I haven't touched. I may have not touched Gemini in the past week. Gemini CLI, that is. I may not have touched Gemini CLI for the past week. Uh, Therefore, I haven't touched the Gemini API for the past week. And it's still going to be like, oh, you've used up your daily quota. Daily means like what? I didn't even touch it yesterday. What daily? You see what I'm saying? So it was apparently a bug with Gemini CLI itself, and that's kind of disappointing. Um, because it makes it a little harder to work with Gemini CLI. Uh, because like every now and then I have to kind of switch the models. Like even yesterday when I was generating this content, doing the pro. So like we are now given an option for Gemini 3 as well, but doing the trying to go with the pro model, I would get the daily usage quota thing. But then when I switch to Flash, because there's different versions of the model available, when I switched to Flash, all of a sudden it was working just fine. Um, Now, give me a second here. Okay, I just need to do something. So I'm gonna, yeah, check something here. Okay, let me resume. Analyze Twitch VODs. Okay. How come I only have 2 chat sessions here? How is it that I only have 2 chat sessions? Chat resume, but that would be with the tag if I've saved a thing here. If I just go for resume, it's only giving me 2. Did it like reset or something? I don't know. Okay, we'll open this up and I will enable this again. Okay, restart this. Let's see how the response time is. Okay, I think we're good. Give me a second. There. Okay, now we are good. Oh, okay. All right. So I was gonna ask Gemini. Okay. All right. These are great. No, these are amazing. Do you have any more techniques to suggest? Given the techniques you suggested above, I'm considering using an LLM, using an LLM plus outlines to to accomplish the various NLP tasks without having to worry about doing a bunch of cleanup on the text first. Do you have any more such NLP suggestions that I could use to, or NLP technique suggestions that I could use to extract useful info from the transcripts and then further use to determine what would be clip worthy. Okay, so this is what I was talking about before. Um, right, so we are gonna switch the model. Um, let's hope this works. Okay, so we're gonna see what the suggestion is here. Since you're planning to use LLM plus outlines, which is a fantastic choice for ensuring structured JSON-ready data, you can move away from keyword searching and towards high-level semantic reasoning. With outlines, you can force the LLM to categorize your stream segments into specific learning objects or engineering states. Here are 5 more advanced NLP techniques that leverage the reasoning power of an LLM to find those technical gems. Okay, the cognitive dissonance marker, error correcting detection. In a technical stream, the most valuable lesson often occurs when your expectation doesn't match reality. That is a bug or a hardware failure. Okay, the technique have the LLM analyze the transcript for expectation versus result gaps, outline schema, force the LLM to output so and so. Okay, clip value. This identifies the troubleshooting arc, the exact moment you realize what's wrong and how to fix it. Okay, all right. Analogy and metaphor extraction. The ELIs. Oh, explain like I'm okay. Educational content is at its best when the creator uses an analogy to simplify a complex concept. Example, think of a pointer like a home address. Okay, all right. The technique, use an LLM to flag comparative pedagogy. Hold on. How do you pronounce this shit, dude? Give me a second. I need to look this up. Give me a second. I'm loading up a YouTube video. Oh, why am I loading up a YouTube video, dude? Hold on. Let me load up Gemini. That's not what I was saying. Okay, let's. Yeah, give me a second here. I'm just waiting for the response.
Hear it differently. The breakdown, dialect, pronunciation, phonetic guide. American English, PEH-DUG-OG, uses a soft G, like Jeep, at the end. British English, PEH-DUG-OG, often uses a hard G, like goat, at the end. Tips for getting it right. 1. Emphasis. The stress is always on the first syllable, PEH. 2. The middle, the da, is a very quick neutral sound, the schwa slash a, almost like d. 3. The ending. If you're in the US, go with the G sound.
I'm gonna stick with pedagogy. Isn't that what I'd first assumed? Pedagogy. What was I saying initially? I don't remember. Okay. Comparative pedagogy. The prompt logic. Identify if the speaker is using a non-technical metaphor to explain a technical concept. Clip value. These are perfect standalone clips for social media or quick tip highlights because they are conceptually dense and easy to understand. Okay, then the recursive importance filter. Sometimes a transcript segment looks interesting in isolation, but it's actually just noise. The technique, use a two-pass importance scoring. Pass 1, extract the main topic of a 2-minute window. Pass 2, compare the topic to the global stream goal. Okay, clip value. This filters out low-value technical moments, like fighting with your IDE or a typo, to keep the high value architecture slash logical slash logic discussions. Then epistemic 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 state. Holy shit. Epistemic state tracking. Wow, that was so hard to like get through. Epistemic state tracking. The new concept flag. In a study stream, you often move from uncertainty, like I'm not sure how this library works, to competence. Okay, I've got the hang of the syntax. The technique, track the streamer's confidence level as a time series. How use outlines to grade your spoken confidence on a scale of 1 to 10. Clip value. Look for the pivot point, the 60 seconds where your confidence jumps from 3 to 8. This is the moment of internalization and usually makes for a very satisfying clip. Okay. Semantic self-containment check, the vlog style hook. The technical clips often fail because they start in the middle of a sentence or lack a hook. The technique, use the LLM to identify introductory hooks and conclusion closures. Outline schema, has verbal hooks, so and so. Okay, all right. Clip value. Instead of just finding interesting content, this finds good video. It ensures the clip starts with a statement of intent and ends with a resolution, making your exported clips much higher in quality. Give me a second here. Okay, implementation strategy with outlines. Since you're using outlines, you can run a hierarchical analysis. Level 1, batch. Take a 10-minute chunk of transcript. Ask the LLM in this 10 minutes which 60-second windows contain a knowledge transfer or successful debug. Level 2, surgical. For those specific windows, use a highly constrained outline schema to find and extract start and end timestamps based on the first and last semantically relevant word. Okay, which of these sounds more useful? Okay, wait. These are amazing. Do you have any more such great techniques for analysis? All right, cool. We've got five more. So I'm gonna later export this to Markdown and then copy this and add it to that conversation. Okay, let's read it from here for now. Um, okay, since you are building and learning the build in public style, your value isn't just in the final result, but in the cognitive process. Your value isn't just in the final result, but in the cognitive process. Here are five more heavy hitter NLP techniques specifically for capturing the logic and architecture of your work. Contrastive reasoning detection, the trade off analysis. In engineering, we rarely just do something, we choose one path over another. These are the most valuable clips for other developers. The technique identifies segments where you compare two libraries, methods, or components. Dude, you know what? This is crazy. This is hold on. I need to have another conversation with Gemini. Hey, so I'm doing currently, if I can spell currently properly, currently, there you go, doing some research on the, sorry, zoned out. Okay. Hey, so I'm currently doing some research on the, sorry, zoned out again. I'm currently doing research on various NLP techniques I can use to analyze a study slash building slash technical live streams transcript to find clip worthy moments in between the research. I realized that I would probably give me a second. Okay, I would probably get much better results if I used an LLM plus outlines, because LLMs are much better at understanding context and also don't struggle, or well, also don't struggle with text that hasn't had a quote unquote cleanup done on it. This has me wondering about legacy NLP versus LLMs plus uh, outlines, because it seems like LLMs are able to do pretty much um, pretty much all. if not all, the stuff we would be using individual uh, NLP models for in the past. Um, Tell me all about the tech behind this. I guess I'm trying to ask the question here because I wanna understand like what makes this possible. Tell me all about the tech behind all of this, and why is it that LLMs are able to outperform legacy NLP uh, methods or legacy NLP models. Tell me all about the tech behind this. Uh, why is it that LLMs are able to so and so? Okay, and what exactly is going on within LLMs and perhaps the transformer architecture that makes this possible? Okay, so we're taking a slight detour here, and we're gonna see if we can. Okay, while this answer is being generated, I'm gonna hydrate, and then we'll continue reading. Okay, all right. It sounds like you've hit so and so. Okay, you've hit the moment that many in the NLP space experienced over the last few years. You're right. The transition from legacy NLP like Spacey, NLTK, or even early BERT-based pipelines to LLMs plus outlines is less of an upgrade and more of a total architecture shift. You know, this is making me wonder if doing the research on or learning all of that NLP stuff that I was learning, this is making me wonder if that is even worth it at this point. Because specifically, I was learning it for being able to apply NLP techniques to low power devices, or well, no, not necessarily low power devices, but low low end devices, let's say resource constrained devices. That's what I was going for. I was trying to apply NLP to resource constrained devices, and using legacy NLP techniques would have been much more lighter than using LLMs. So like for like real time output, I wanted to use legacy NLP techniques. But then as I'm going into this, as I'm exploring NLP more and more, I'm starting to understand that I'm starting to understand why LLMs excel over legacy NLP techniques. Because, like, this is a good example, isn't it? Like, okay, in order to do keyword tracking or keyword spotting, um, like you'll run this model, but then the model is dumb because it's one of the legacy NLP models. The model is quote unquote dumb. So it's going to spot the keyword, but it might even spot the same keyword in a situation where you say that you're not planning on doing whatever that activity is. So just because the keyword was spotted doesn't mean it's something useful. So then you have to then explore that sentence and understand what the context is there to see if you need to keep it or not. And then there's also the concept of the disfluencies, where you have stuff like that. You have these filler words that you're putting in. Then you also have punctuation that you need to worry about. Like if your sentence is a run-on sentence, maybe the model is going to struggle with it. Um, there's the filler, but yeah, uh, apparently LLMs don't have this issue. So at this point, I'm wondering if I should be putting more of my effort into LLMs and less into legacy NLP methods. Okay, hold on. I'm going to start up a new conversation with Gemini. I'm going to ask this question as well. Okay. Um, okay, we have this and this. Okay, because it seems like LLMs. Wait. Oh, there was a lot that I wrote here. In between this, I realized that so and so, so and so, so and so. Okay, this has me wondering about. This has me wondering about legacy NLP so and so. Okay, all right. More specifically, because I'm currently doing deep learning research, um, learning about different, learning about various architectures, and am planning to eventually also study the transformer architecture. Um, wait, more specifically, because I'm currently also so and so so and so, I'm wondering if I should be spending more time towards learning legacy NLP or towards researching making LLMs more and more lightweight enough to run in real time and get real time results um, quickly. Because also um, I'm also using. Oh wait, we're also going to be doing that LLM course, right? I feel like we're going to learn a lot from that from the LLM course. Yeah, you know what? Yeah, yeah. Okay. Because I'm also using the transformers. Okay, I don't need because there. Okay, I'm also using the transformers library for various projects. Okay, let's see what the answer is here because I kind of need to decide like what do I want to put my time more towards. Okay, that is a fantastic pivot. Transitioning from legacy NLP, NLTK, Spacey, or even BERT-based classifiers to LLMs plus structure generation, which is outlines or instructor. Instructor, what is that? Is that also a library similar to okay LLM instructor? Multi-language library for structured LLM outputs. Was this mentioned before? Did I see this before? Apparently, it's available in Python, TypeScript, Go, Ruby, Elixir, and Rust. That's crazy, dude. Instructor is the most popular Python library for extracting structured data from large language models with over 3 million monthly downloads, 11K stars, and 100 plus. Hold on. If this is so popular, is there transformers support in this? That's important because I'm using transformers based libraries. Um, I need to see like some example that mentions transformers. Hold on. Installation, why instructor, repo, okay, mode comparison, philosophy. Okay, why use instructor? You've built something with an LLM, but 15% of the time it returns garbage. Parsing JSON is a nightmare. Different providers have different APIs, and there has to be a better way. Okay. You know what? Okay. All right. With instructor, automatic retries with validation errors. Oh, okay. Hold on. Hold on. It always returns valid user object or raises clear exception. Each provider is different. Every LLM provider has its own API. Anthropic, OpenAPI, OpenAI, OpenAI. It's not mentioning transformers. Hold on, let me just search for the word transformers. Okay, sentence transformers popped up here. Okay, automate example selection and then document segmentation with LLMs. Okay, let me Google this. So, outlines versus instructor. OpenAI's structured output versus instructor and outlines. Okay, comparison between outlines and other structured outputs. So and so. They're compared here. This is a longer article that talks about the various structure generation techniques employed and so and so. Okay, you know what? I was planning on going with transformers. I was planning on going with outlines initially because it had explicitly mentioned transformers support. So I think I'm gonna stick with outlines for now because they're explicitly like showing what is it called? They are explicitly showing or exclusively showing transformers API, like using the auto model for this, auto tokenizer for that, and stuff like that. So I think I'll stick with that. Now, for my next answer, or well, to continue with that answer that Gemini had given, you're right that the transition. You're right. The transition from legacy NLP to LLMs plus outlines is less of an upgrade and more of a total architectural shift. Here's how. Here's a breakdown of why LLMs have essentially swallowed the classic NLP stack, and the specific magic under the hood that makes it possible. The legacy problem, fragmented pipelines. In traditional NLP, a task like find a clip-worthy moment, I like that it's remembering, oh wait, no, this is part of this conversation. Okay, never mind. Would require a fragile chain of specialized models. You have the tokenizer, split the messy transcript into words. Part of speech tagger, identify nouns and verbs. Named entity recognition to identify people slash locations. Sentiment analysis to check if the speaker sounds excited. Summarization model to condense the text. The weak link, if the transcript is messy, example, so anyway, the building code, the tokenizer might fail, which makes the POS tagger fail, and by the time you reach the logic phase, the data is garbage. These models are often local. Uh, they look at small windows of text and lack a global understanding of why a moment is interesting. All right. Why LLMs win? The transformer and self attention. The reason LLMs can handle a raw transcript without cleanup is the transformer architecture, specifically the self attention mechanism. Parallelized context. Older models like RNNs or LSTMs read text like or read text like a human, left to right, one word at a time. By the time they got to the end of a long sentence, they often forgot they often forgot the beginning. Transformers, however, look at every word in the sequence simultaneously. When the model processes the word it in a 500 word transcript, the self attention mechanism allows it to attend or give mathematical weight to a noun mentioned 300 words earlier. Oh, okay, so that's how it's able to still maintain context. So, like, because of the way that it works, when we refer to it, it is still able to detect or determine that it here is referring to something that was mentioned, like, I don't know, three, four sentences earlier. Though this mentions 300 words earlier, which is crazy. Like, that's wow. For your use case, an LLM can understand that a speaker's current excitement. Actually, yeah, now that I think about it, if I'm talking about a certain topic for a good like 5, 10, 15 minutes, at a certain point, I'm just going to start saying it rather than repeating that name over and over again. And so, over how many ever sentences, the what it is referring to, um, that context can be lost. But apparently, an LLM can maintain that context. Okay, for your use case, an LLM can understand that a speaker's current excitement is actually a payoff to a joke that started 5 minutes ago. A legacy model would just see excitement, would just see excited sentiment, quote unquote, without the context of why. Okay, emergent reasoning. Because LLMs are trained on basically the entire internet, they don't just learn grammar, they learn concepts. Legacy NLP sees the word concrete and tags it as a noun. LLM knows that concrete in a building live stream relates to structural integrity, drying times, and potential failure points. It can reason, quote unquote, that a discussion about a crack in the foundation is a high priority clip, even if the speaker isn't using excited keywords. The outlines magic, constraint generation. You mentioned using outlines, which is the final boss of this workflow. The biggest fear with LLMs is hallucination and unpredictability. If you ask an LLM for a JSON list of clips, it might add a conversational, sure, here are your clips, which breaks your code. Yep, true. How outlines works technically, instead of letting the LLM choose from its entire vocabulary, example 50,000 plus tokens for every word, Outlines uses regex or JSON schema based FSMs, finite state machines, to mask the model's brain. If your schema says the next character must be a number, Outlines sets the probability of all non-number tokens to zero. The LLM provides the contextual brain, while Outlines provides the structured rails. This allows you to extract high-level clip logic directly into a database-ready format without any post-processing cleanup scripts. Okay, so this has me wondering, wondering something. I plan on learning about the transformer architecture later. I also plan on going through the LLM course on Hugging Face. Um, if I want to work on or do research about LLMs and building LLMs, do I still need to concern myself with legacy NLP methods, or is it mainly concepts that I need, mainly NLP concepts that I need to learn and then learn how to implement them in an LLM, or um, are LLMs a whole different ball game, and I just need to stick to LLM specific concepts? This is a fantastic question that gets to the heart of what it means to be an AI engineer versus machine learning researcher. The short answer is you don't need legacy NLP for the execution of tasks anymore, but you absolutely need the concepts for the research and optimization of LLMs. Here's how to think about the legacy versus LLM divide as you head into your Hugging Face and research journey. The concepts are immortal. While you might never write a custom lematizer or part of speech tagger again, the linguistic concepts behind them are still primary ways we evaluate and debug LLMs. Tokenization in legacy NLP, this was just splitting text. In LLM research, tokenization is a high level science. In LLM research, tokenization is a high level science. If your tokenizer is bad, your model can't do math or spell. You need to understand how meaning, quote unquote, is broken into numbers. Then embeddings and vector space. Traditional NLP used word to vec or glove. LLMs use much more complex contextual embeddings, but the core math which is representing a word as a coordinate in a high dimensional space is exactly the same. Then n-grams and self-attention. Understanding how we used to look at local patterns, which is n-grams, helps you appreciate why self-attention, which is global patterns, is so revolutionary. While legacy NLP is still the boss, even in 2026, there are scenarios where using 100 billion parameter LLM is like using a rocket ship to go to the grocery store. Yeah, okay. Scale and cost, deterministic data cleaning, evaluation. Okay. The research gap. If you want to build or research LLMs, you are moving into the realm of architecture and data science. Data curation. The secret sauce of the best models like Llama 4 or GPT-5 isn't just the code, it's the data cleaning. The people doing this use legacy NLP techniques such as duplication, language detection, quality filtering, etc., to prepare the trillions of tokens required for training. Oh, that's interesting. Okay, so NLP, legacy NLP is still used then. Okay, mechanistic, mechanistic interpretive, oh my God, mechanistic interpretability. Holy shit. This is a hot research field. It it's the study of why a certain neuron in a transformer fires. To explain it, researchers often have to map those firings back to, you guessed it, classic linguistic concepts like subject verb agreement or entity extraction. Your learning path, my recommendation, since you're about to start the Hugging Face course, here's a mental framework I'd suggest. Don't memorize legacy code. Don't spend weeks learning how to manually turn a hidden Markov model or a support vector machine for text. Tune, not turn. How to tune a hidden Markov model or a support vector machine for text. Focus on the why. When the course mentions tokenization, softmax, or cross entropy loss, actually two of those things I've already learned with feed forward neural networks. So that's a plus point. The minus of that is I've forgotten what the calculation was, which is why I'm glad that I actually looked into the calculation rather than just rather than just being satisfied with saying, oh yeah, this is a loss function. I wanted to learn about the loss function because it turns out cross entropy loss does involve softmax, like implicitly. Give me a second. Okay, focus on the why. When the course mentions tokenization, softmax, cross entropy, okay, pay attention. These are the mathematical gravity of all NLP, legacy or modern. Then master the pipeline. Hugging Face is built on the idea of a pipeline, understanding how data flows from raw text to the tokenizer to the model to post processing is the most important skill you can have. Okay, the verdict: treat legacy NLP tasks like classical physics. You might spend your career working on quantum physics, which is LLMs, but if you don't understand the basics of motion and gravity, linguistics and tokenization, um, the big stuff won't make sense when it breaks. Okay, this also has me wondering, is there a chance I could, I would eventually be able to run an LLM on a low end device and get real time output, or, well, get output um, quick enough that it could be used for real time purposes? Because I know that they're making much smaller versions of models now, and they are actually able to run on lower end devices. So I want to see if Gemini can, enlighten me on some of the research that's taking place. Okay, in 2026, the answer is a resounding yes. We have officially crossed the threshold where low end no longer means incapable of AI. The dream of running a private real time LLM on a device with modest specs like a mid range phone or a standard laptop has become a reality thanks to a pincer movement in technology. Models are getting smaller and more efficient while hardware is becoming more specialized. Okay, the hardware revolution, NPUs. The big shift isn't that CPUs got faster, it's that we stopped using them for AI. Most modern devices now ship with a neural processing unit. GPU versus NPU. Wait, this is a thing? Neural processing unit. Okay, GPU versus NPU. While a GPU is a jack of all trades for parallel math, an NPU is a specialist. It is hardwired specifically for the matrix multiplications that transformers use. Efficiency. NPUs in 2026 can deliver 50 to 60 tops tera operations per second while using a fraction of the power of a GPU. This means you can run a model for hours without your phone turning into a hand warmer. The software squeeze, model compression. To fit a giant model onto a small device, researchers use three primary techniques that you'll likely encounter in your Hugging Face course. Okay, quantization, the weight loss. Imagine a model's brain is stored in 16-bit numbers. Quantization squashes those down to 4-bit or even 1.5-bit numbers. You lose a tiny bit of quote unquote intelligence, but you reduce the memory footprint by 75% or more. Okay, speculative decoding, the speed hack. A tiny dumb model, um, the drafter, quickly guesses the next five words. A large smart model, the verifier, checks them all at once. If the tiny model was right, you just generated five words in the time it usually takes to generate one. Okay, that's interesting. Then knowledge distillation. This is the teacher student method. A massive 70 billion parameter model, which is the teacher, trains a tiny 1 billion parameter model, which is the student, so it mimics its logic. The result is a small language model that punches way above its weight. What real time looks like in 2026. For your specific goal of analyzing live streams for clips, here's how the performance stacks up on a low end device. Okay, Llama instant transcription and basic clip tagging. Optimized mid range, deep context analysis. Okay. Legacy NLP would be 1,000 plus tokens per second. That would be incredibly fast. But it requires pre filtering silence or ums before the LLM sees it. Oh, wait. Oh, this is suggesting passing it from one model to another to another. That's interesting. Okay. The outlines advantage again. Okay, okay. So, what I was thinking about was more along the lines of hardware built in the past, say 5 years or so, being able to run LLMs real time. I feel like I'm really pushing the question here because, or I'm pushing the ability in terms of what am I trying to say here? I feel like I'm really pushing it in terms of trying to question whether LLMs can do stuff real time or not. Because for my specific purpose, the only time I'm going to be doing real time is with that specific situation, like where I was trying to make a topic graph kind of application. And but I can definitely see situations where people might want real time. And so I'm like, um, what about other situations? You know, like maybe there might be a bunch of other situations where real time would be useful. Okay, let me ask this question. Actually, you've hit on one of the most exciting shifts in AI. You don't need a futuristic 2026 supercomputer to run these models. Most hardware from the last 5 years is surprisingly capable of real-time LLM performance. The trick is that while the models are getting smarter, the software running them has become incredibly efficient at squeezing performance out of old silicon. The 5 year okay, if a machine from the early 2020s, if you have a machine from the early 2020s, here is how it likely performs today. Okay, so NVIDIA RTX 30, okay, that's a GPU we're talking about. Then we're talking about Apple M1, M2 chips. This is all GPUs. Okay, here we're talking about AMD Ryzen CPUs. If you don't have a GPU, a modern if you don't have a GPU, modern CPUs with AVX 512 instructions. Wait, weren't they? Oh shit. Okay, so I remember the vectorized operations being 128 bit, but I'm guessing now we have like even longer. So like you have like an even wider. So if it's 512 bits, I'm assuming 512 bits. I'm not sure. I'm gonna have to look into that. If it's 512 bits, then that means the register can hold 512 bits at once, and that is like divided into, hold on, 512 divided by 8. That's 64. Wait, that's crazy. Wait, is that right? No, hold on. No, no, no. That doesn't make sense. No, no, hold on. That doesn't make sense either. No. Um, is that right? 64 bytes? Let me, yeah, yeah, okay, no. If 8 multiplied by 64 is 512, that means we can store 64 bytes on the actually, you know what? No, hold on. That's, I mean, I'm excited about that, but if you look at multi-byte data types, like you have int 32, int 64, float 32, float 64, those are going to be like multiple bytes already. Either way, it's still cool if the register is able to hold 512. Hold on. So I know a little bit about vectorized um, CPU instructions. I've learned that apparently um, it means that the CPU can load multiple pieces of data into the same register and then perform vectorized operations on all that data at once. Thereby, yeah, yeah. I was about to say thereby making it vectorized, but I already mentioned vectorized. Oh, thereby making it SIMD. If I'm right about this, does AVX 512 mean 512 bit registers. You've got the core concept exactly right. You're essentially describing a wide pipe versus a narrow one. Instead of processing one 32-bit integer at a time, the CPU packs a bunch of them into a single massive register and hits them all with the same instruction. Single instruction, multiple data. To answer your specific question, yes, AVX12 means the CPU uses 512-bit registers. Breaking down the math. To visualize why 512 bits is such a big deal, look at how much data fits into a single ZMM register, the name of the AVX512 register. Okay, yeah, it's showing it here. So we can fit um, eight 64-bit floats, 16 32-bit floats, 16 32-bit integers, and 64, which we already calculated, 64 8-bit integers, which is a byte. The evolution of the width. Okay, so we had seen AVX and AVX2. There was SSE. SSE was 128-bit. Okay, and then AVX and AVX2 were 256-bit, and now AVX 512 is 512-bit. That's crazy, dude. Okay. Also, it's kind of interesting. The old one, the very first one, the 128-bit registers, they were called XMM, and the next iteration, which was AVX and AVX2, so the 256-bit registers, they were called YMM, and now the 512-bit registers are called ZMM. Okay, it's not just about the width. While the 512-bit register is the headline feature, AVX 512 introduced some clever logic that made it more intelligent than its predecessors. Op mask registers. These allow the CPU to mask certain lanes. If you have an if statement in your code, the CPU can tell the register to only perform the operation on elements 1, 3, and 5 while ignore. That's crazy, dude. Okay, conflict detection. It can detect if different elements in the vector are trying to write to the same memory address, which helps with vectorizing complex loops that were previously unvectorizable. Then more registers. AVX 512 doubled the number of available registers from 16 to 32, which reduces the time the CPU spends swapping data in and out of the cache. Hold on, I need to check if... Wait, so what all do I have? I have an i5 5200, I think. Give me a second, I need to look at BTOP. No, i5 3570. Okay, and then here I believe I have an 8500, or maybe it's a 5200 here. Man, okay, hold on. I've had a conversation. Hey, I've had a convo with you in the past about three core i5 CPUs that I have. Do you happen to remember them? I'd love to say I have perfect digital memory of our past chats, but I actually don't have access now. Hold on. Okay, so I'm gonna have to take a guess here. Actually, okay, I have two things that I could look at. This one has 5,200, then the other one probably has 8,500. I'm guessing it's an 8,500. I don't know. Okay, so I'm gonna take a guess here and say I have, wait, a guess here for one of them. I know the other two. And say I have Core i5, what is it? 3750, um, 5200U, and this is a guess, 8500U. Can you tell me which SSE, which and how much? SSE, AVX, what am I? AVX, AVX2, and what's the other thing? Oh, further from that point, it's just called AVX 512. Okay, AVX 512 registers are supported on them. Okay, it looks like you've got a mix of a desktop workhorse and two mobile U series chips. I did a quick double check on those model numbers. Oh, okay, it gave me a suggestion. Okay, I did a quick check on the model numbers because there's a small correction to make. There isn't actually an i5 3750. You likely have. Oh, that's crazy. Okay, yeah, Gemini is right. I got it wrong. I read it as 3750. It was 3570. Is that what I read previously when I was reading the thing out? I don't remember. Okay. Um, right. Core i5 3570 and or an i5 8000. Oh, there isn't actually a Core i5 3750 or a Core i5 8500U. You likely have the popular i5 3570 and the i5 8250U. You know what? You might be no. You know what? You are right. Core i5 um, 3570 and um, i5 8250U. Okay, glad we got that cleared up. Okay, so what are we looking at here? We are looking at. Okay, so neither of my CPUs seem to have the AVX 512 registers. However, all of them have the 128-bit registers, so that is possible. All of them have the AVX registers. Two of them have the AVX2 registers, and yeah, then none of them have the 512 registers. Okay, so what's the difference between AVX and AVX2? Hey, what's the difference between AVX and AVX2? Okay, the jump from AVX, Advanced Vector Extensions, to AVX2 was one of the most significant updates in the x86 instruction set in the last decade. While they both use the same 256-bit YMM registers, the vocabulary they use to talk to those registers changed drastically. The vocabulary they use to talk to those registers changed drastically. Think of AVX as a specialized tool for floating point math, decimals, while AVX2 turned into an all purpose powerhouse. Okay, so AVX was specifically for a floating point, but then AVX2 allows everything else. Okay, AVX was primarily focused on floating point operations. It could handle big 128-bit registers using older SSE instructions, but it couldn't use the full 256-bit wide registers for whole numbers. Wait, AVX primarily focused on so and so. It could handle 128-bit integers using old SSE instructions. Oh, so even though AVX did introduce 256-bit registers, it wasn't able to use those 256-bit registers for all the data types. It had to use older registers for something like an integer. Okay, then AVX2 expanded almost all integer commands to 256-bit. This meant it can process twice as many integers, like 32-bit or 64-bit whole numbers, in a 64 no in a single sorry in a single clock cycle compared to the original AVX. Then FMA3, fuse multiply add. AVX usually required two separate steps to multiply two numbers and then add a third. Wait, multiply two numbers and then add a third. Why? Like this seems familiar, but like more for linear transformations. What is that doing when you're doing it with like integers and floats? Hold on. In my deep learning studies, I've learned that um, a linear transformation is two matrices being multiplied and then a bias being added. But what do you call it when we have A multiplied by B plus C, and all of them are scalars? It's easy to get caught up in the big matrix energy of deep learning, but you are hitting on a fundamental concept. What you are dealing with when you are dealing with simple scalars, the operation y equals a multiplied by x plus b is formally called an affine transformation. Okay, in common parlance, the and most high school math classes, it is often referred to as a linear function. However, wait, hold on. A multiplied by x plus b. Isn't this the thing for a line? Yeah, mx plus b. Isn't this the function to draw a line? I completely forgot about that. Okay, anyways, however, there is a subtle nerdy distinction between linear and affine that is actually quite important to deep learning. Hey, you know what? No, I'm not gonna get into this because I'm gonna get too sucked into it, and then I'm gonna lose a lot of time. And I'm already like I've branched out way too much here. You know what? Okay, let's step away from the AVX thing. Um, Vectorized operations, we've understood that as well. Great. NLP, so and so. Okay, what is here? Terms explained. What was the prompt? How do I clean up the text? Oh, yeah, no, that's not what I'm looking for. Okay, okay. You know what? All right. Yeah, I'm pretty much at the end of the stream. We are pretty much at the end of the stream. I'm gonna look for someone to raid because I have some stuff to do. Give me a second here. I'm getting suggestions for some newer people that I could possibly raid. Um, Actually, nah. Okay, you know what? Yeah, we're gonna. Nah, you know what? I'm just gonna end the stream because I have a couple of other things to do, and yeah, I won't be able to stick around and chat with the person. So I'm just gonna end the stream here, and I'll stream again tomorrow. I have like a bunch of research to do now because now we're not going to be using legacy NLP techniques. We're going to be using LLMs all the way, which means I need to start learning how to use outlines. These are two things that we need to do. I need to add that to the list. Where is my list here? Um, Content pipeline, uh, generate video metadata. Okay, learn how to use. Okay, description. Um, Learn to use outlines library. And then I already have this. Let me also add polars. Polars, sliding 60-second windows over so-and-so, logic. Okay, yeah, that's gonna be it for today's stream. I have like a bunch of stuff that I have to go over and kind of get back on track with working on the content pipeline. Two things that we need to figure out right now, or two things that have priority right now for the content pipeline are one, the sliding windows, because we're not going to get anywhere until we are actually able to create these chunks of text. And the only way I can do that is with sliding windows. Um, and the next thing that we're not going to get anywhere without is the outlines library, because I need the LLM to give me structured input, structured output. So if I tell it to give me, so and so information in this exact format, I need it in that exact format because the next step is expecting data in that exact format. So if it doesn't get the data in that format, then things break. And once we have both of these things figured out, which also reminds me, yeah, I need to continue learning the basics of polars. I need to rush with that because yesterday I didn't do that because I decided to take a short detour to practice some Lua, and then I just got kind of sucked into that just to kind of refresh my Lua knowledge, and yeah, that happened. So today I'm gonna kind of continue with that Lua thing, but also I'm gonna try and get back on track with the polars stuff. I need to finish learning the basics of polars so that I can then start doing this rolling sliding window thing. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.